Hey there, Geometry. Thanks for tuning in for another episode of Math with Mullins. Today we're going to be looking at our Chapter 3 test review, so let's go ahead and get started. Finding the values of x and y and then state the theorems that you used. For x, we know that should be equal to 61 degrees because of the vertical angles congruence theorem. Y is also equal to 61 degrees, and you could use a few different ones. You could use corresponding, or if you said that x and y are alternate exterior angles theorem, you could use that as well. Both of those would work for your reasoning. Let's go on to number 2. Again, finding the values of x and y. I know at first I started off with x. I know 8x should be equal to 9x, to 96 because of the corresponding angles theorem. Which just means x is equal to 12. And then for y, I also used, you could technically use corresponding angles, or you could use the vertical angles theorem. Which just means 96 is equal to 11y plus 19. So that when you solve for this, you subtract 19 from both sides. So 96 minus 19 should give us 77. And then y then is equal to 7. Number 3, again, the same type of deal. I started with x. I, in this case, said 8x plus 2 plus 6. Well, I guess first I started with y, just because I realized these wouldn't be equal to one another. 8x plus 2 is equal to 42. And I know that because of the alternate interior angles theorem. So when I solve for this, I get 8x is equal to 40, so that means x is equal to 5. And then for solving y, if I know that this is 42 degrees, then I can say 42 plus, I'm going to go and distribute this, 12y minus 18 is equal to 180. And that one was the supplementary angles theorem. Or you can also say the consecutive angles theorem, and that will help as well. So to solve this, I put together 42 minus 18 first. 42 minus 18 gives us 24. So now I'm going to have 12y plus 24 is equal to 180. Then I'm going to subtract this 24 from both sides. Whoops. 180 minus 24 is going to give me 156. And then dividing both sides by 12, y is equal to 13. Okay. These next two examples, number 4 and number 5, take a little bit of time. So let's go ahead and start talking about here. This was back in lesson 3.4 and 3.5. We start with finding the perpendicular slope. Okay, that perpendicular slope for this one is going to be a positive 1 because it's the opposite reciprocal. So now that I have that, I'm going to use point slope form and plug in my x1 and my y1. So I'm going to have y minus y1, so that's y minus 4, is equal to m1 parentheses x minus x1, so x minus 3. When I distribute that, I'm going to get 1x minus 3, add 4 to both sides to get y by itself. So y is equal to 1x plus 1. This is going to be your new equation. Okay, so then I take my original equation, negative x is equal to y, and plug that in and substitute it. So negative x is equal to 1x plus 1. I'm going to subtract 1x from both sides. So now I'm getting negative 2x is equal to 1, and if I divide both sides by negative 2, x is equal to negative 1/2, okay? What I do now is I plug this into my original equation of y is equal to negative x. So y is equal to negative 1/2, which means y is equal to 1/2. So my new point should be negative 1/2, comma 1/2. Now I'm going to find the distance. So this was the part 2. Now I'm going to find the distance between negative 1/2, comma 1/2, and that original point 3, comma 4. Okay, so that is distance formula y2 minus y1, or you can even do x2 minus x1. So that's 3 minus negative 1/2 squared plus 4 minus 1/2 squared. 3 minus negative 1/2 is 3.5, so I'm going to say 3.5 squared plus 4 minus 1/2 is 3.5 squared. 3.5 squared is 12.25. So I'm just adding those 12.25s together. That's going to give me 24.5, which comes out to be about 4.9 units. And I just rounded that to the nearest tenth. Okay, so yes, there is a lot that goes on here using point slope form, finding your perpendicular slope, using a lot of substitution. But once we get those steps down, not too bad. We're going to try the same thing here. So step 1 is to always find that perpendicular slope. So in this case, the perpendicular slope should be negative 3. Now that I know that, I'm going to do my x1, y1 and plug that into point slope form. So I'm going to have y minus 7 is equal to negative 3 parentheses x plus 3. The reason why it's x plus 3 is because x minus negative 3 automatically changes to that positive. Let's go ahead and distribute. So y minus 7 equals negative 3x minus 9, and then add 7 to both sides. I'm going to get y is equal to negative 3x minus 2. This is going to be your new equation. So now we're going to substitute original equation, 1/3 x minus 2 for the y is equal to negative 3x minus 2 to get my x value. Okay. One thing I probably would do here is you want to go ahead and get your x's to one side, or even your 2's. Maybe I would start with the 2's. If I add 2's to both sides, those are just going to give me 0. So I have 1/3 x is equal to negative 3x. That means I'm going to have to add 3x to both sides. And if you want to, you can say this is just 3 1/3, or 10/3. I'm going to say this is 3 1/3 x is equal to 0, because negative 3 positive 3 is 0, so that means x would also be equal to 0. Now that I know x is equal to 0, I'm going to use my step 2 and plug that x equals to 0 back into my original equation to get my y. So y is equal to 1/3 times 0 minus 2. So y is equal to negative 2. So my new point is going to be 0, negative 2, and my old point is negative 3, 7. Now let's find the distance. x2 minus x1, that's negative 3 minus 0 squared plus 7 minus negative 2 squared. Negative 3 minus 0 is negative 3, and squaring that gives you 9. And then 7 minus negative 2 is 9. 9 squared is 81. Then I'm going to add those together. I get 90. So we're finding the square root of 90, which is about, rounded to the nearest tenth, 9.5 units. Okay. The rest of these should go by pretty simply. Find the value of x that makes m parallel to n. X is equal to 97. Number 7, I know that these are equal to one another because of the alternate exterior angles theorem. So if I set 4x plus 24 is equal to 8x, I can go ahead and start solving. First step, minus 4x from both sides. I get 24 is equal to 4x. So I know x is equal to 6. Number 8, these are not alternate interior or alternate exterior, but you could use your supplementary angles theorem. I know that 6x minus 6 corresponds to this angle right here, and they should be making that supplementary angle. So I know 6x minus 6 plus 11x plus 33 equals 180. As a supplementary angle, combine like terms, 17x, and then negative 6 plus 33 is 27. That equals 180. Then I'm going to take that 180 and subtract 27 from both sides. I get 153 is equal to 17x. So last but not least, I'm going to divide both sides by 17. 153 divided by 17 should give me a value of 9 for number 8. All right, writing an equation of the line that passes through the given point that is A, parallel, and also perpendicular to the line. So let's start with parallel. I know that parallel means I need to have the same slope. So I'm going to use the same number, and I'm going to use y2, my point slope form, where x1 and y1 are already labeled for me. So y minus 2 is equal to 2, parentheses, x minus negative 5. That becomes x plus positive 5. And then I just simplify. Y minus 2 is equal to 2x plus 10. I'm going to add 2 to both sides. So y is equal to 2x plus 12 is the parallel equation. Okay? You do the same thing, but for perpendicular, my perpendicular slope is negative 1/2. So y minus 2 is equal to negative 1/2 parentheses x plus 5. Simplifying that, y minus 2 is equal to negative 1/2 x minus 5 halves. I'm going to add 2 to both sides. Adding 2 is like saying I'm going to add 4 halves, which is negative 1/2 now. So I have y is equal to negative 1/2 x minus 1/2. This one would be your perpendicular slope, or your perpendicular line. Okay, number 10 was the same way. Parallel means the same slope. So here's my x1, here's my y1. Y minus y1 would be y minus negative 9, so that's y plus 9 is equal to perpendicular slope. Let's go ahead and, parallel, we'll do that first, is negative 1/3. And then parentheses x minus negative 1, which would be x plus 1. Let's go ahead and simplify. I have y plus 9 still is equal to negative 1/3 x minus 1/3. I'm going to subtract 9 from both sides. Subtracting 9 from 1/3 is like saying it's negative 27/3. So you're going to get negative 28/3. And then negative 1/3 x still hanging out there is equal to y. So here is your parallel equation. Perpendicular is going to have a positive 3/1. So this one's a little bit easier. Y plus 9 is equal to 3, parentheses, x plus 1. Simplify, I got y plus 9 is equal to 3x plus 3. Subtracting 9 from both sides, I should end up with y is equal to 3x minus 6. And that is your perpendicular equation. Okay, 2 more to go. Number 11, a student says because J is perpendicular to K, J is perpendicular to line L. What is missing from that information, and what theorem could you probably use? What this student needs to say is J is perpendicular to K, and maybe K is also parallel to L. So K is parallel to L. That means that L can now be perpendicular to J. So the person trying this, maybe they were trying the perpendicular transversal theorem. And that just means that both lines K and L need to say that they are parallel before you assume that L is also perpendicular to J. 13 was the last bit. Now I'm going to have some examples here. You might not have had the same thing, but as long as you know what skew lines should be, perpendicular lines, etc., you should have gotten this correct. So skew lines, I chose AB and GH because they're non-intersecting, they're non-coplanar, and they're non-parallel. Perpendicular lines, I chose IJ and EF because I can see right here, IJ, there is a 90-degree angle hanging out right there. A pair of parallel lines, I chose line IJ and line KL. You could also do CD and EF, so those are working as well. Congruent corresponding angles, angle 1 and angle 3 are congruent corresponding. An alternate interior, that'd be angle 2 and angle 3. Okay, that concludes our review for chapter 3 in geometry.